It's your friendly math tutor, Miss C, here to unlock the magic of choosing elimination or substitution for solving a system of equations. First things first, we need to decide which method makes the most sense. So for substitution, I want to ask myself, can I easily isolate one variable? Or can I get one variable on its own side pretty easily? The first equation, not so much, but the second equation, this x, is pretty easy to get by itself. All I have to do is move the 5y over. For elimination, I want to ask myself, is there a variable I can easily eliminate from both equations? So I'm looking at the equations together. So what I notice is I could very easily get 5x and x to cancel out. Could multiply the second equation by -5, and voila, that variable's gone. If I look at the y values, yeah, 4 is negative and 5 positive, so that's great. But I would actually have to be multiplying both equations by different numbers to be able to eliminate y, and that sounds like an awful lot of work. So I think we're going to stick with x. So let's go ahead and we're going to work through each of these methods, and you can choose for yourself which method you find easiest. So I'm going to start by doing substitution. And when I do that, I'm going to go ahead and I'm going to take the second equation and I'm going to get x right here by itself. So to do that, I'm going to go ahead and divide my equation into two halves, so the left half and the right half. And then I am going to subtract 5y from both sides because I'm trying to get x on a side by itself. So 5y minus 5y is 0. 0 plus x is x. So I just have x on this side equals 1 minus 5y. These are not like terms, which means they cannot be combined. So that is the solution there. All right, now that we have x isolated, I'm going to go to my other equation, the one I did not manipulate. So that would be the very first one. And everywhere I see x, I'm going to substitute in 1 minus 5y. So here we go. So I'm going to go ahead and write 5, and I'm going to leave a parenthesis. I'm using a parenthesis because this substitution has two terms, and I have to use parentheses when I do that. So now I'm going to go ahead and substitute everywhere I saw x right here. I'm going to substitute this piece in 1 minus 5y, those two terms. And now all I need to do is solve for y. So to do that, I'm going to go ahead and distribute 5 times 1 is 5. 5 times -5y is -25y. I'm just going to rewrite the rest of my equation because it keeps it neat and orderly. When I do that, I see I have two like terms on the left side of the equation. So I'm going to go ahead and combine those. So -25y minus 4y is -29y. And then there's 5 on the other side. Now I need to get my y term by itself. So to do that, I'm going to subtract 5 from both sides. That leaves me with -29y equals 0. Well, that's good for us. That means a little less calculation. Divide by -29 on both sides. I've run out of room. When I do that, that makes a 1 times y. So y equals 0. But we're not done yet because we still need to figure out what x is. So everywhere I see y, I'm going to make sure y'all can see this. I'm going to make this a little darker. Everywhere I see y in this equation, and I'm using this equation because x is already solved for, it's by itself on its own side, I'm going to substitute 0. So in this case, x equals 1 minus 5. I'm going to put my parentheses there, and in goes 0. I keep picking a color y'all can't see. X equals 1 minus 5 times 0, which is 0. So that means x equals 1. So my solution to this system is x equals 1, y equals 0. I could write it like this. That is the point that if these two lines were graphed, they would intersect at 1, 0. All right, so that is how we do substitution on these equations. All right, now let's try it with the elimination method and figure out if we prefer substitution or elimination, or which is faster, easier. It varies by person and it's completely up to you. So here's how we do elimination. We are going to choose the variable to eliminate. And as we talked about before, the x's are going to be the easiest ones to eliminate because we only have to manipulate one equation to make that happen. So what I'm going to do is I need to figure out what the opposite or the inverse of 5x is. The inverse operation of 5x is negative 5x. So I want to take this entire equation and multiply it by negative 5. The reason I'm doing that is because I'm creating an equivalent equation. To do that, you have to multiply the entire equation by the same value. Otherwise, it's not the same equation. It's a different equation. So I'm going to start by rewriting the top equation just as is because we are not doing a thing to that equation. And now I'm going to distribute this negative 5 to every term in the bottom equation. So negative 5 times x is negative 5x. Negative 5 times 5y is negative 25y. Negative 5 times 1 is negative 5. And now let's just double check that we actually eliminated the x variable like we planned. And we're just going to say, is 5x minus 5x 0? If it is, we eliminated it, and it is. And now we're just going to combine these like terms in both equations. So we're going to read this as negative 4y minus 25y is negative 29y equals 5 minus 5 is 0. And now we're going to divide by negative 29 on both sides. And look at that, y equals 0, which is what we got on the last problem. All right, now we have the option of picking any of these equations to substitute y equals 0 in for. I, of course, like the shortest possible option, so I'm going to choose this equation because x is pretty much by itself. And everywhere I see y in this equation that I'm going to leave with parentheses, I'm going to substitute in, you guessed it, 0, because that's what we just found. So 0 goes in there. And now I'm just going to simplify. X plus 5 times 0 is 0 equals 1. X plus 0 is 0. So x equals 1. All right, that's what we got. So again, our solution is 1, 0. Just like we had on the last one, this is where these two lines would intersect if they were to meet on a graph. So this is our solution. So what do you prefer? Substitution or elimination? Sometimes equations don't allow for both of these options as easily as this one does, and then you really have to decide. But either one works here. If it were up to me, I would choose elimination because it was much faster than substitution in this case. All right, thanks for joining me and unlocking the magic of choosing substitution or elimination when solving systems of equations. Make sure to subscribe for more math videos. Till next time.